Welcome back to my YouTube channel. Please click subscribe. So give me a thumbs up. And click here for notifications. Alright, welcome Mosi. Alright, so when you get a question like this, and you will get a question like this, the first thing that you do is you are going to look at all the compounds that they give you, and you're going to say to which homologous series do they belong to. Okay, so if we look here, we see there is a double bond. So Declan, to which group does it belong to? I'm not at the first question. I am looking at the compounds. A. To which group does A belong?
That will belong to the alkene.
Okay, alkenes. The next thing that you do is you write down the molecular formula for the compound. The molecular formula. This is C4, because you can see 4 carbons. And then H, 1, 2, 3, 4, 5, 6, 7, 8. Or you could have said, okay, alkenes, the general formula is that. So you could have easily gotten C4H. 8. The next one, to which group does it belong, Siamo? B, number B. A Declan. Also the alkenes. And what is the molecular formula, Liakwe? For B? Mooi. So they are what of each other's? Isomers. Mooi. Alright, then the next one, butene. Mama, to which group? Butene. Alkenes. And Boki, what will the molecular formula be for butene? Wait. So that is also an isomer. Okay. Then we have this one. C, 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 and then double O, H. Tawana, to which group does this belong to? Yes, the carboxylic acids. And what will the molecular formula be for that one, Antoinette? C? No, how many C's? Yes. Shh. Yes. Wait. Right, then the next one, Princess. Methyl propanoate. To which group does it belong to? Propanoate. It is the esters. Okay, and Jabu, what will the molecular formula be? Meth tells me how many carbons? Meth. Sorry. What? Prop is how many? And meth is? So it will be? The general formula is CnH2nO2. So what do we see about these two? Isomers. Alright. Then the next one, to which group does this belong to, Declan? Number F?
Isn't that the protein?
There's a C double bond O.
No, that's the ester.
No. Carboxylic acid looks like this.
Is that the
It is a ketone. The toe is sticking out, but the toe is in the middle somewhere. It's not at the end. Ketone. And some of the molecular formula? Yes? See what? H O How many O's? One. So is that isomer of that one? No, the number of oxygens differ. Alright, and then the last one there. To which group does it belong to, Antoinette? I'm taking the side now. You are correct in thinking that. And what will the molecular formula be, Tawana? Think, read, look. Five. H. Ten. Okay, so what they try to do here is they try to confuse you between G and B and G and A. Because they look, especially B and G, when you look at them, they look like they could be isomers. Alright? But then you realize, no, this one has 5 carbons, this one has 4 carbons, they cannot be isomers. Alright, so each time you get a question like this, so this will always be your second question in chemistry, you do this, you write down to which series does it belong to, and you write down the molecular formula. Okay, now, they ask, write down the letter that represents a chain isomer of compound A, Bokkie. Compound B. Okay, because what is a chain isomer? It's just the length of the parent chain must differ. So here you can see the place where the double bond is exactly the same, and it should be. It's just this one is 4 carbons and this one is 3 carbons. Okay, so that will be B. Then the positional isomer, mama, of A. It is C, because this one's name would be but 1-ene. Sorry, but 1-ene, because the double bond is on the first carbon, and this one is but 2-ene, it's on the second carbon, so it will be C. Then they want the functional isomer of D, Liakwe. You said E is correct, because they are isomers, they have the same molecular formula. This one is a carboxylic acid, this one is an ester, so their functional group differs. Right, and then write down the IUPAC name of compound B. Okay, so what I want to do, and here I'm going to start now here. Compound B is this, that. Okay, so what do? We always highlight our main chain, or the longest chain that has the functional group in it. Then I have my side chain there. Right? And I remind myself I have something weird there. Then where do I start counting, on the right or the left? The left. Why? Because it's closer to my first, or to my functional group. Okay. So, the main chains, Liakwe, did you answer now? Yes, you did. Jabu. The main chain is how many carbons? 3 was. Okay, and then? Do we have to say prop 1-ene? No, because it can only be on the first carbon. So propene. Then what else do you see, Princess? We have propene, and then? And where's the meth? But is it necessary to say on the second one? Because it can only be on the second one. It cannot be on the first or the third. So yes, you can say 2 meth, but... Okay, and what's the suffix for a side chain, Princess? Meth? Where's your head today? You are thinking correctly. So this one's name would be methyl propene. Sorry, I wrote in Afrikaans. Okay, then question 3 they ask. Write the molecular formula for compound C. Molecular formula for compound C. Compound C was but 2-ene. They didn't ask for the structural formula. They're not going to draw in all the carbons. They just want the molecular formula. Now, what I would do is I would say, right, this belongs to the alkene homologous series. So the general formula is that one that I studied. Okay, that's the general formula. They want the molecular formula. Is that right? How many carbons do I have? Bute tells me I have 4 carbons. So C, 4. And then my H will be 8. Okay, question 4. Write the structural formula for compound E. Compound E was methyl propanoate. Okay, so we said that belongs to the esters. Job, what did you answer now? Question. What did you answer?
My answer before it's
Okay, it's your turn. It's Esau. Can you please? Alright, Tiamo. This belongs to the esters. What does the functional group of the esters look like? The functional group of the esters, what does that look like?
it's 3 carbons.
Just the functional group. Where's the O? Okay. That all?
No, I'm going to double after on top of the C.
Okay. Alright. So that we must have. Now, propanoate refers to the parent chain. The parent chain is this one that is bonded to that double bond O. Pro means how many carbons? 3. So we must have 1, 2, 3 carbons. Then methyl refers to the side chain that is after the oxygen. Meth refers to 1. So we're going to have after that 1 carbon. And then you fill in your hydrogens. Remember, if you miss a hydrogen in the test or an exam, you lose a mark. Yes.
If you just draw the line of the H's as well.
We just did like that because we were lazy in class. But now we are done being lazy. Alright, yes, you could have written it in mirror image, right? So then it would be C double bond O, O, C, then C, like that. Okay, methyl propanoate. Right, then question 5 says, write down the structural formula of the functional group of compound C. So not the whole thing, not the whole compound C, just the functional group of compound C. Now compound C is but 2ene. We said it belongs to the alkenes. So Declan, what does the functional group of the alkenes look like?
The 4 carbons.
No, not the whole structure, just the functional group of the alkenes. Say again? No, I couldn't hear.
Where the double line is P.
Yes.
Yeah, so it's on the second carbon.
I'm not at second carbon at all. It's just the alkenes. Between 2 carbons, there's a double bond, and each carbon can make 4 other bonds. That is what you must draw. That's all. Because they ask, look at question 5, they say, write on the structural formula of the functional group. Not the whole thing, just the functional group. So if you drew, see, like that, you will get, I can't say how many marks it counts. I think it counts 2 marks, then you'll get 1 out of the 2. If it counts 1 mark, obviously you get 0. So not that, not the whole thing, just the functional group, just the thing that makes it different. Alright, then question 6. Can I take this away? Okay, question 6. I said write the name the IUPAC name of the compound that has a carboxylic group. A carboxyl group. So you had to know, so this is a difficult question, because you had to know that the carboxyl group we find with the carboxylic acids. Then you had to know that D was a carboxyl group, and that is CH3, CH2, CH2, COOH. And then you have to give the name. Okay. Now, how many carbons do we see, Antoinette? 4. Right. So it's bute. Right? Then, Tawana, how are we going to complete the name for a carboxylic acid? What is the suffix? So it's butanoic and then acid. Butanoic acid. So did you see my thought process? They say, write the name of the compound that has a carboxyl group. So I asked, all right, which one has a carboxyl group? The carboxylic acids have a carboxyl group. And then I had to find that one's name. Can you see why it's so important to write this down for each and every one of them? Okay. Then number 7. They say, is compound A saturated or unsaturated? Give a reason for your answer. Boki, what did you say? Compound A saturated, unsaturated? Why? Where is the double bond? Yes, but this also has a double bond on a carbon. But this is not considered unsaturated. This is considered saturated. What is the wording that I'm looking for? I said this a couple of times in class. Saturated, the double bond is, Chabu? Between two carbons. So you can't just say there's a double bond on a carbon. There's also a double bond on a carbon. Between two carbons. Okay, so we're going to say that it is unsaturated. And then you say why? Because there's a double bond between two carbons. Question 8, they ask, write the name of the homologous group to which compound B belongs to. So compound B, to which group does it belong to, Mama? Alkenes. Okay, so question 1 is always theory. Alright, so what I'm going to do now is I'm going to hand out to you, or for you, I just want to check. I'm going to hand out, because I haven't given us those booklets with past papers. Past papers from an old booklet. Alright, who's taking for Mosi? Alright, so if you look at the questions, just want to go through it. On page 9, it starts with organic molecules, nomenclature, I can't pronounce that. Okay, so that goes on. So that's the type of questions that we did now. Isomers, give the name, blah, 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 blah. That goes on until the end of page 16. Then on page 17, we start with, are you paging with me? Page 17. We start with physical properties. Okay, so that's the next chapter from this chapter. Next question from this chapter. That has to do with boiling point and intermolecular forces that we already did in grade 11. Alright, but we're just going to apply it to this chapter. And then that goes on until page 23, that's the memo. On page 23, then you handed the questions to Leakwe, and she doesn't have a memo. Where's the other one? Yeah, but you have 2 papers. Well, okay, alright, I'm going to hand it now. So do you have 2 papers now? Okay, so on page 23 you see not halfway, just underneath that question it says organic reactions. So that's the 3rd chapter from this chapter. We haven't done that yet. Okay, so in here at this moment you must be able to do all the questions from page 9 up until page 16. You must be able to do. So that's practice for the test. And then you see the memo is given to you. For the test, you're supposed to be able to do all of this, all practice. So we have a bit of work to do until next week. When are you writing? Next week. Next week when?
Thursday.
Monday.
Thursday.
Okay. Alright. So I haven't heard. It's like we are not finished with the whole chapter. Okay. It's not like we didn't do our part. We had Saturday classes. We had extra time. We made the timetable longer to fit in work. So if the question paper has a question in that we can't do yet, then I'll tell you that morning. Please leave this question and this question and this question. I'm not going to put extra pressure on you. Unnecessary extra pressure. Alright. Okay, so let's go to the next part of the work. That is the intermolecular forces. So that is on page 16. Yes. No! I gave you a list at the beginning of the year. This and this and this. It's so much. 1 paper, 100 marks. It says on that ATP. Where's that ATP? Where's that thing that I handed out? Take out. Where's that page that I handed out to you? No, not that one. No, not that one. Let me give you another one. How is that possible? Did you not receive that? Sorry.
She's all making mistakes.
Alright, are you taking form or say advance? Yeah. Alright, so, huh? I feel like I just give it 45 minutes.
We can help.
Yeah. Aha. Hoki has it, so it means that I did give it. Okay, but anyway, you can see there at the end, there, it tells you what do we write on. Thank you. It says there, we write 1 question paper, 100 marks, 2 hours, 50 marks physics, 50 mark chemistry. The physics is Newton's laws, momentum and impulse, vertical projectile motions. Chemistry is organic molecules, so it's this whole chapter. Why is it? Alright, so thank you. So we must get moving. Okay, so the next chapter of this, I told you in this chapter there's 3 chapters, is just this one page 16. Okay, is the next chapter because we have already done this and I've spoken about it as we went through all the molecules. Okay, so firstly, this whole next chapter, next part, has to do with intermolecular forces, or we speak about physical properties. Okay, intermolecular forces or physical properties, and that's just this one page. Okay. So first, there's a few definitions that you must know. The first one there is viscosity. Viscosity, what is that? It's a measure of a liquid's resistance to flow. How difficult or how easy does something flow? And it says here, the stronger the intermolecular forces, the higher the viscosity. Okay, and that is when we did those chains. I showed you a video as well of the long chains and it goes into the chamber and blah, 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 blah. If you think about those long chains, tar, that we tar the roads with, does tar pour easily? No, it's almost like lava. It takes a while and it goes whatever. Because it's very long molecules, very strong intermolecular forces, so it doesn't flow that easily. But if we have short molecules, then it does flow quite easily. Alright, yes, Mama?
So last year you gave an example of syrup and water.
Yes, what about that? Okay. Yes, the same syrup and water, but they have different type of intermolecular forces. So I didn't want to compare the two. Okay, because syrup has London forces, water has hydrogen bonding. Hydrogen bonding is then stronger than syrup, but it's because syrup has very long molecules that it takes more. So I don't want to compare two things with different intermolecular forces and different lengths. Right. Then one that they ask quite a lot is the definition of vapor pressure. Vapor pressure is the pressure a vapor exerts above a liquid. What is vapor again? The particles that are already vaporized, evaporated. Right? So vapor is if we have, let's say we have a container, a glass. And the particles have already started to evaporate. Go up in the air. That is the vapor pressure. The pressure a vapor exerts above a liquid. Vapor pressure. Okay, so what do I explain on the right hand side? The stronger the intermolecular forces, the more difficult it is for a liquid to evaporate. Because if they are tightly bound, they do not want to break and form a vapor. So the stronger the intermolecular forces, the more difficult a liquid will evaporate. And thus the lower the vapor pressure. So in our head, we can actually think that vapor pressure is inversely proportional to intermolecular forces. Okay? Please do not say this in words like they are inversely proportional to one another. Okay? Because you're only allowed to use proportionality in words, like they are inversely proportional to each other, when there's a formula that goes with it. For instance, we have this formula. Yes? Then we can say acceleration is inversely proportional to mass. But we do not have a formula linking these two. This is just a concept. Okay, so then you can't use the word inversely proportional. You can say that the stronger the vapor pressure, the stronger the intermolecular forces, the weaker the vapor pressure, or the lower the vapor pressure. Right, and then the last definition that they also ask quite a bit is the definition of boiling point. That's a difficult definition. The temperature at which its vapor pressure is equal to the atmospheric pressure above the liquid. Okay, now if you leave out the word the temperature, if you just say where, you get no mark. If you say where the vapor pressure is equal to the atmospheric pressure, no mark. You must say the temperature. You can either say at which or where vapor pressure. You can leave out above the liquid. Alright, then the higher the higher the vapor pressure, the lower the boiling point. Okay, so what do we mean there? So if an object or a liquid evaporates fast, so then you don't have to heat it up to say for water we need to heat it up until 100 degrees Celsius for it to start to boil. Yes? If something has a high vapor pressure, meaning it evaporates quickly, then we don't have to heat it up a lot. We can heat it up to 20 degrees Celsius before it starts to boil because it evaporates quite easily. Okay. Right. Then we're going to compare 4 different things when we look at this chapter. We are either going to compare intermolecular forces, or we are going to compare the number of functional groups, or we're going to compare the chain length or surface area or molar mass, or we're going to compare branched versus non-branched. Okay, so when we compare, before I start there, let's say I use this example in grade 10 as well. When we want to determine who is the fastest boy in school, okay, can we compare a grade 8 learner with a grade 12 learner? No, it's unfair, because in grade 8 your hormones haven't kicked in yet, but in grade 12 it has, so that will influence your muscles, blah 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 blah. Alright, so we can't compare that. We can't compare a boy with a girl, because again, you build differently, your hormones are different, blah 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 blah. Right, so if we want to have a fair comparison, then we must say, alright, if we want to know who is the fastest boy in school, we have to keep it at a boy, we have to keep it at a certain age, and we have to keep it at a certain distance. Right? Because we can't compare a 100-meter athlete with a 1,500 meter. Okay. So we have to keep a lot of things constant, and we can only keep one, or we can change one thing. Okay, so right, we're looking at 100 meters and how fast. So the time would be what we measure. So with this is very, very, very important. When we compare the strength of the intermolecular forces, for instance, then our chain length must be the same. Our functional group must be the same. And our branch or non-branch must be the same. We can't compare intermolecular strength, so say compare London forces with hydrogen bonding, and the one chain is short and the other chain is long. Okay, so there can only be one independent variable. Okay, now strength of intermolecular forces, we did this as we went on, but I just did a summary here for you. If we look at alkanes, alkenes, alkynes, oh sorry, there must be a K. They all have London forces. Then esters have dipole forces, aldehydes, dipole, ketones, dipole. You can see here that esters have the smallest dipole forces, then aldehydes, then ketones. So ketones is the strongest, then aldehydes, then esters. And then alcohols have one site for hydrogen bonding, and carboxylic acids, the strongest, have 2 sites for hydrogen bonding. That is something you need to know, study, off by heart. Sure? Okay, now, if we look at the boiling point, let's say we compare a carboxylic acid with an alcohol, ethanoic acid with ethanol, and I ask you which one will have a higher boiling point. You can say, alright, first we look at the polarity of the functional group. We're going to say carboxylic acids have 2 sites for hydrogen bonding, alcohols have 1 site for hydrogen bonding. Thus, the intermolecular forces for carboxylic acids is stronger. Thus, more energy will be needed to overcome the intermolecular forces between carboxylic acid molecules. Thus, it has a higher boiling point. Do you remember this from last year? Yes. Yes. Okay, so here I did the summary for you, and I also did it for the vapor pressure. I just want to look at the vapor pressure because it's a bit more difficult. Again, let's say we're going to compare ethanoic acid with ethanol. Okay, so carboxylic acid with alcohol. Alright, between the two, again, ethanoic acids have 2 sites for hydrogen bonding, alcohol has 1. Ethanoic acid has a stronger intermolecular force. Thus, more energy will be needed to overcome the intermolecular forces, and then an extra sentence. Thus, ethanoic acid evaporates at a slower rate at the same temperature. I want you to add in there, at the same temperature. It evaporates at a slower rate at the same temperature. Slower rate at the same temperature. Thus, it will have a lower evaporation. Okay. Right. So, intermolecular forces, I think you understand. Number of functional groups. What do I mean there? Let's say you compare propanol, propan 1-ol with propan 1,2,3 triol. Okay, so the same chain length, but now this one has one functional group, this one has 3 functional groups. Which one will have a stronger intermolecular force? The first one. There? Because here we have one side for 100 bonding, here we have 3 sides for 100. Alright, that's more energy will be needed to overcome the intermolecular forces, that's how I want to put it. Okay? Then chain length of surface area or molar mass. This is, let's say, when we compare this one versus, sorry, here I wanted to put in versus. Which one will have, okay, so you can see what's the difference between the two? Is the chain length. What is the same thing between the two? What is this thing that is kept constant? They're both alkanes. So we're comparing an alkane with an alkane. It's not an alkane with an alkene or an alkane with an alcohol. So same homology series. This one is just longer. So you can either say it has a longer chain length, or you can say it has a bigger surface area, or you can say it has a bigger molar mass. Okay, they're all linked with one another. So if the chain length is bigger, then the contact surface is bigger, or the surface area is bigger. Thus it has stronger intermolecular forces, thus blah, 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 blah. Alright, then branched molecules. So if we have this versus this. Which one do you think? Oh, sorry, both must have 4. Which one do you think will have stronger intermolecular forces? The first one or the second one? Why the first one? Yes? It's almost like building blocks, right? Or if you have like Velcro, if you must rip something, you know, when something placed against each other, no? Yes, Velcro. I don't think I have Velcro here. You know Velcro? Where is Velcro? Yes? Oh, I think the netball, when you play netball and you want to paste on what position you play, they were like, do they have buttons? I don't think they have buttons, like you can rip it off. Yes. Like that. So that is Velcro. Okay? Yes. For? No, it's not used for waxing, but you can think of it as the same. Okay? If it's a long chain without any bumps or things in it, then they can paste nicely, right? And then it's difficult to rip it off. But if there's a bump in it, okay, then they don't paste as nicely against each other. Okay, so let's say we have that, and now I have something sticking out. Then I can't paste something nicely over it. There will be gaps in between. Okay, so the forces keeping them together have gaps in. Okay, so it's more easy to rip them apart because they're not pasted everywhere together. Okay, So the same thing here. If it is a straight chain, then a contact surface is bigger. So if there's fewer branches, the contact surface is bigger, so the intermolecular forces is stronger. Alright. Okay, so what we are going to do to practice this is on, sorry, I just want to check, did I not do it here? No. Is on page, I think it's the last page, yeah, this page. Okay. Let's see. They say consider the boiling points of the following alkanes. Okay, and you can actually do it on this page. That's why I left a bit of page open. Okay, we're going to look at them. Now, before you look at them, before you read the questions, we're going to look at to which group do they belong? Alkenes, alkanes, alkynes, whatever. And their molecular formula. Alright, so let's just look. Propane belongs to what? Okay, oh sorry, here they say they're all alkanes. Alright, never mind. Alkanes have all what type of intermolecular force? London intermolecular forces. So they all have the same type of intermolecular force. They all have London forces. Alright, propane, how many carbons? 3. So C3H8, I think. Methyl propane. How many carbons? 4. How many hydrogens? 10. Butane? 10 hydrogens. So what is methyl propane and butane? They are what of each other? Isomers. What type of isomer? Their functional group is the same. They're both alkanes. Not position, chain isomer. Because there's the position of the weird thing did not change. It's not like it was 1 methyl propane and now it's 2 methyl propane. Okay? The whole structure of the parent chain changed. The length, so it's a chain isomer. Right, and then pentane, how many carbons? 5. Okay. Then you can see here, here's the molar mass. This one, and then they are bigger, but they are the same. Why they're the same? Because they have the same molecular formula. And then this one is a bit bigger. Then we can see here that the boiling point increases when we go like this. Okay, so we can say butane, even though these two are exactly the same, butane has a higher boiling point than methyl propane. Okay, so we know a question is coming there. Alright, now let's ask them. Explain why the boiling point of pentane is higher than that of butane. So we must compare pentane with butane. Yes? Yes, exactly. That's why we did it in last year. So that this year you get your 4 marks. Okay. So they say refer to structure, strength, and energy in your answer. Now they're not going to say that to you like this in metric. Okay. You have to know that you have to give those 2 points. Of 3 points. Okay. So we are at 1A. Now I just quickly want to recap those points that we want to touch on. Okay, so the first point that we must touch on is always what? The obvious difference between butane and pentane. What is the difference? Then we want to touch on the intermolecular force, right? This one has a stronger intermolecular force, this one has a weaker intermolecular force. Then we want to touch on energy. Thus more energy will be needed to overcome, and thus less energy will be needed to overcome, blah, blah. And the last thing is then you want to make your conclusion regarding boiling point or vapor pressure or whatever. Okay, so that is just our summary of all the points that we must touch. Okay, so at A, they say we must compare pentane with butane. That's what they said. Okay, so we're going to start with the obvious difference. What is the difference between the two, Leakwe? Okay, that's the similarity. What is the difference? No, but well, the question is, why is the boiling point different? You can either look at what we have written down or what they gave you. Alright, so you can say here, so now we look at the chain length. We can say pentane is a longer chain, or you can say pentane has a bigger mass. Okay, or you can say the surface area is bigger. So we're going to say Aitoch. Alright, so I want you to please do this then for homework, this question. Okay.